far, especially from this tree.
Did you guys take Map 127 with Dr. Wong?
Yeah, of course, we can calculate that.
Oh, hey, guess what? I got this cool little device. It's called a clinometer, and it can measure up to the slope of the mountain. And we can calculate the height and the distance to the top of the mountain. And if you look through it to the top of the mountain, I can't get that in there, but, oh yeah, I can, there we go. Check it out. You can measure the slope to the top of the mountain.
Standing at the base of the tree, we use the clinometer pointing at the peak of the mountain to find the angle of elevation of the mountain. Looking at the clinometer, we find that the string falls at about 79 degrees. Subtract 90 degrees from 79 to get 11 degrees. 11 degrees is the angle of elevation of the tree. Now, we need to find the distance between the tree and the mountain. To do that, you need to know that approximately 1 degree of latitude and longitude is approximately 69 miles. Using the degree, latitude, and longitude, 69 miles, and the coordinates that were given, calculate them with the distance formula to find the distance. The distance is approximately 1.66 miles. From there, we can use that to help us find the elevation of the tree. We need to convert miles into feet. 1 mile equals 5,280 feet. Multiply that by the miles we found, the 1.66 miles from the tree to the mountain, to get 8,764 feet. Take that number there, multiply it by tangent of 11, which is the angle of the tree, to find a number 1,703 feet. Take that number and subtract it by the elevation of the peak of the mountain. The elevation of the peak of the mountain is 4,094 feet. Subtract that by 1,703 feet to get 2,390 feet, which is the elevation of the tree.
Okay, our problem here, we have side angle, side triangle, and it's an aerial view. So our goal is to find how high peak B is. In order to do so, you must find the length from A to B first, using our law of cosines. Next, you find your length from C to D, using your law of sines. Once you have this length, then you can get the length of A to B, using our law of cosines. After we accomplish that, we're going to draw our third triangle. And this is going to give us our height of peak B. Okay, so we're going to use our law of sines to determine the length from A to B. Once we have A to B, we can find our B to A1. And this B to A1 is our elevation of our peak. And then once we find our height, then we convert it to meters, and then we're going to add our sea level amount.
What is that? Okay, wait, say it again. So I'm not talking. Say, what is that?
What is that?
What is that? It's a clinometer. It measures. Oh my god! It measures angles. I can't. Okay, so what is that? It's a clinometer. It measures angles, slopes, and distances.
What are you doing?
Playing with my clinometer.